High-speed, large-capacity data communications are required with the spread of communication devices such as smartphones. This requirement can be met by optical fibers for communications. Smartphones and other communication devices communicate with base stations installed on towers and rooftops via radio waves. Communication between base stations and connection to the Internet are supported by high-speed communication over optical fiber networks. The thin transparent wire at the end of the coating is the optical fiber. Optical fibers are made of silica glass with a diameter of about 0.1 millimeters. With hundreds of millions of light pulses per second, it is possible to send large amounts of data at high speed. For optical fibers, multiple fibers need to be aligned ribbonized to improve the efficiency of fusion splicing. However, conventional ribbon fibers are bonded throughout their length, so they are not resistant to distortion, such as twisting, and slot protection is necessary. Fujikura has developed the spiderweb ribbon SWR, which is easily deformed, resistant to distortion, and spreads like a spider web. Optical cables are required to have smaller diameters, lighter weight, and higher density. The structure of wrapping tube cable, WTC, maximizes the features of the spiderweb ribbon, SWR, which does not require slot protection and thus enables a smaller diameter, lighter weight, and higher density. Specifically, we have succeeded in reducing the diameter of optical cables with 1,000 cores by approximately 20%. In addition, the 1,000 fiber optic cable has the same diameter as the previous 2,000 fiber optic cable and has 2 times the number of the cores. By thinning the coating of each optical fiber, we have developed a 3,000 fiber optical cable with the same diameter and 3 times the number of the cores. These technologies have been integrated into the ultra-high density optical cable. The number of optical fibers in the 35 mm diameter is 6,912, the highest level in the world. Fujikura is also working on increasing the density of cables from a different perspective. A single fiber typically contains 1 core in the path of light, but this fiber contains 4 cores. The transmission capacity can be increased with the increase in the number of the cores. This is called a multicore fiber, and Fujikura is researching ways to further increase the number of cores. Fujikura's optical fiber fusion splicer boasts the world's top share, offering reliable connection quality and ease of use. We are also promoting research on multi-core optical connectors to connect optical fibers together. The MPO connector is a single connector used to connect and disconnect 24 optical fibers. When connecting the optical connector, cleaning the end face is necessary. This one-click cleaner is also available for easy cleaning. Fujikura will continue to support communications infrastructures through optical fiber with its world-class technologies. Tsunagu technology supports safe and secure town development. Fujikura